So today's session again is going to be 2 hours. We've already started, and we're going to focus on how do you launch containers, what are the options that you commonly use, how the images, where do the images come from, how the images are structured, what are the common options that you use, -it, -d, how do you troubleshoot your applications and containers in general. Once you launch it, you may want to check logs, you may want to get inside the container shell. We'll look at those aspects. We'll look at the 3 ways to port map. That's how you make your applications available outside. We're going to look at a bunch of other operations, including how do you control resources. Controlling resources is basically leveraging the underlying Cgroups functionality that we spoke about in the previous session. And these are the topics that we are going to start talking about. And let me jump to my slides right here. Let me also arrange it. All right. Yeah, so this is the presentation that I would be using. Again, I would be sharing the presentation, lab guide, and the treasure hunt towards the end of the session. So make sure you stay on so that you receive all of those information. There's a 22 pages of lab guide that you're going to find. It's very detailed. You're going to find it very useful, especially when you start learning on your own, right? So here we go with running and operating containers. I already have an environment set up. I assume all of you should have an environment with Docker set up. How do you verify your environment? Let's begin with that. So you run Docker version. Okay. All right. I have an annotation on, but I don't want you to do that right now. Right. Okay. Let's try that later. Okay. So how do you validate your Docker setup? There are a couple of commands that I recommend. First is Docker version. Now, what do you see when you run Docker version? You see the client and the server. You must see both of these components in order to validate your setup right. And what it actually does is it shows you the client, which is your Docker CLI. It also, if you see this part, the server or the daemon is started. If you don't see this, there is definitely a problem with your Docker server-side component here. And you may have to start the service, you may have to start the application. So, you need to go and figure out what is the problem there. You also see the version of Docker. Both these versions are same right now, 19.03.11. If you look at the version, 19 represents the year 2019. This was created in the March of 2019. The first stable version of this major release was released in March of 2019. And 11 is the 11th iteration, which is pretty recent, which was released on the June 1st. So until we have the next major release, we're going to continue to see 19.0.3 something, 11, 12, and this number would keep on increasing until we have a new major release or a minor release there. Now, the second command that I typically use is docker run hello world. This is a smoke test. Why this is important? You should see this message when you run docker world hello world. And why this is important is actually launches a container. So if you have any proxy issues, if you have any network issues, if you have any internet issues, if you have any other issues, you generally will see some problem right here. If this works, you're pretty sure that your application, your containers are going to run fine, and you should be able to work with it. So these are the two smoke tests and validation commands that I use: Docker version and docker run hello world. Now you can also find out more information using some of these commands. One of that, which is very useful, is docker system info. Now this command, docker system info, we would be referring to this a lot. And what does it show you? When it says docker system info, it's mainly the server-side information that you're looking at. So every command that you run actually connects to the Docker daemon, even if it is remote, over a RESTful API call, and returns this output. And you can see that how many containers are running, the one I just launched, how many images I have, what is my server version, storage driver. So you're going to see all the information related to your Docker daemon. And we would come back to it, refer to it again throughout the session that we conduct today. The next command that I want to start with is docker system events. Now, you don't see any output here, which is okay. and that is an expected one. What is happening is Docker system events is actually pulling the information from my Docker server. Since there are no events happening, there is nothing running, there's nothing else is happening, I do not see any events. But the moment I start running my first container, you are going to see a bunch of events, come appearing right here. Time to launch our first container. Again, even though you can run these commands along with me in parallel, I do not recommend it right now. The main reason being, I don't want you to miss out on the concepts which go behind it. And if you understand that, you can follow up and quickly do the lab, maybe in an hour or so, or even maybe in an hour or a couple of hours. So time for doing the labs and running these commands is later. Just pay attention right now. If you have any questions, you can raise it. Try to make sure that you understand all of these concepts clearly. Now, when we launch these containers, what actually happens? Let me try and explain that first. And so the containers, when you run them, containers need to have an image. And the first thing that you need is that image. Now, where does this image come from? And all of this is going to run on your Docker daemon. So where does the container run actually is wherever your Docker daemon is, right? Not the client. Your client can be your Mac or your Windows, and you might have a Linux server which is running remotely. So your container is going to run here. And it needs an image. Where does this image come from? Let's actually look at it. Images come from the registry. An example of a registry is Docker Hub, or maybe Azure Container Registry, or ECR, or there are many private registries also. And this is similar to GitHub, actually. Just like GitHub, there are repositories here, and each of the images is stored in one of the repositories, right? Every repository, we're talking about a repository, not just one image. Let's say, even if I say Ubuntu, there might be different versions of the Ubuntu. So there might be Ubuntu 18.04, Ubuntu 24, Ubuntu 16.04. So it is basically, Ubuntu is a repository. 18.04, 16.04, 20.04 would be one specific version in that repository. And for every image, let's say there is an Nginx, there is a Maven. So every image that you have would be part of this repository. And this is where the images are pulled from. Now, talking about the registries, specifically, let's take an example of Docker Hub, right? It is based on the concept of same as GitHub, basically. So there are parallels here, but the differences are basically, when you look at GitHub, GitHub stores the source code. It's a repository of source code versus Docker Hub is the repository of images. And just like GitHub, you have a repository. Typically, a repository is represented by a namespace or a username, user, organization, or whatever it might be right here. And then the actual repository. And then you may have a tag and so on. Similarly, Docker Hub also has the images, which can be represented by the namespace and the repository. And then it has a version. Now, each repository can have multiple tags in GitHub as well. So every release that you create might have its own tag. Similarly, you might have different tags inside Docker Hub as well, right? So those are the versions, different versions of your images, right? So that's how the difference between GitHub and Docker Hub looks like this, basically. Now, I'm going to begin by pulling the image first. From where? From a specific repository, which is Alpine 3.12. And how do I pull that? Is using Docker image pull. And then the name of my image, that is Alpine, and represented by a specific version, which is 3.12 in this case. Now let's actually look at the images, right? Each image that you can launch with Docker contains actually up to 4 fields. I say up to 4 fields, right? So not necessarily that every image is going to have all those 4 fields. Our image here is just two of these fields. Let's look at what are the fields which are available in an image. The first field is the registry. Typically, if you do not see this part, it means that it's using a default version of the registry, which is typically a Docker Hub. Second is the namespace, just like a user, organization, or maybe a project. The third is the actual repository. Fourth is the tag. Let me actually, show this to you by browsing to the Docker Hub repository, which is nothing but hub.docker.com. And let's take an example of the same Alpine image. Now, why do I use this Alpine image is because of the footprint that it has. So if I search for Alpine, I may see a bunch of images listed here. There is one here which just says Alpine. That's the one we are using. But you also have Alpine Hem, Alpine HTTP. So this is basically organization or a repository or a project, right? So there might be different ways to, different naming conventions that you may want to use here. And when it comes to tags, these are the versions. So this Alpine image is a repository of different versions represented by different tags. There's the latest version, there's the Edge version, there is this version. We're using 3.12 version of this image. And if you look at this, it does not have a username. And that is because this is an official version of the image created by Docker. And since we are using Docker Hub itself, we don't have to provide the registry because we are pulling it from Docker Hub. We don't have to provide the user because this is an official image. It's also called as a root namespace, right? So if you do not see this, this belongs to the root namespace, which is owned by Docker. If you don't see this, there is a default. Everything has a default here. And if you don't see this, basically this comes from Docker Hub. And this is also how you pull your own images by providing your own registry. So a common question is, hey, I want to use a private registry. How do I do that? All you have to do is provide your registry name here. Let's say xyz.acr is Azure Container Registry.io, and then your username, and then the repository, which is Ubuntu. This is the tag. So if you look at the command that I'm showing you here, and this is the one I'm going to run, it's actually pulling the repository and the tag. There is no user because it is an official version of Alpine, and there is no registry because it is coming from Docker Hub. So let me actually pull this image. Let me show you whether I have an image already. Alpine doesn't exist. Hello World does because I run a container with already. And this is a command that I would use to list the images. In fact, if you want to find out the list of commands which are supported, you can just run Docker, and it gives you all of these flat commands, as well as there is a category of commands. Like the one I'm using is Docker image pull. So Docker image pull, Docker image RM, Docker image ls, similarly Docker container ls, and so on. Now we have the categories as well. So this is the new way of organizing the commands. Earlier it used to be just Docker run, Docker ls, Docker images, and so on, which exist even today. But since Docker started adding a lot of features and a lot of functionalities, new functionalities, they started categorizing it into these management commands. So there are a lot of commands. You might find it confusing because it's you can use Docker container run versus Docker run as well, and the reason for that is the legacy way of doing it versus the new way Docker designed. Let me pull this image, Docker image pull, Alpine 3.12. Okay, observe the system events here. This is going to tell you what happens on the Docker daemon side. So what is happening is that with this client, this is the client, we are talking to the Docker server, and these are the events which happen on the Docker server. It has pulled the image, and now you can see the output here. The pull has completed.
Sorry to interrupt, Gaurav. Just one quick question. Since we are gonna use the term Docker client server daemon multiple times in the session, just want to have a quick brief about how can we distinguish between a client Docker. This is a particular Docker client, and this is a particular Docker server.
It's very easy. If you see a command which starts with Docker, it is 100% client. You don't talk to Docker server directly. To talk to the Docker server, you always use a client. It could be either a command like this, or it could be maybe a UI. So either of that is your client. So whatever interface that you use is always a client. You don't talk to the server directly, right? So the server accepts only the RESTful API calls. If you were talking to a server, you would have either a long command or a put, your get request or a post request and so on. So we don't want to do that. So we use a client. So any command that you use is always a client side.
So we can say that if we are using Docker client, we are just putting our commands over there and the Docker server is executing those commands at the backend.
Exactly. Everything happens on the server side. We use client only to talk to the server. So whenever I run even this command is actually, there is nothing happening on the client side. This is just the client. This
Okay.
client talks to the server and then it actually returns the output, and that output is represented or the shown here, displayed here. So client is just like a dumb client. It knows only to talk to the server and the information comes from the server. So this information comes from the Docker daemon or the server always. All right.
Thanks.
And
Yeah.
yeah, so we're going to go and launch our first container with Alpine. So how do you launch your container is using Docker container run. So what is actually important here, a very important concept here, and that differentiates your container from a VM is with a VM, you can launch a virtual machine and not bother which command to run and all of that while at the time of launching. You can just launch a VM and then later on decide what to run inside it, or just keep it running, with a shell and no other additional process. But with a container, it's different. You always have to define the objective of why do you need that container. And the reason for that is a container is nothing but a process running in contained or isolated environment. So if there is no process, there is no container at all. So you always have to define what process, what command, what application to launch. And in this case, it is uptime. This is the most important part. And then how do you run it is using Docker container run. Now, when you run it, you need an environment, and that environment is provided by the image. And this is why you need an image. Since we are running uptime, it doesn't make a much difference. But if imagine you wanted to launch Tomcat. Now, when you wanted to run Tomcat, you would need an image which has a Tomcat installed. And that's why this environment or the image is important. Now, Docker Container Run is the new style using the management or the category. You can also run this same command using just Docker Run. And that's what I'm going to use. I'm going to keep it simple and I'll just use Docker Run. We're using Docker to run what? To run uptime. Where does this uptime come from? Uptime comes from this environment, this image called as Alpine. So let's launch it and see how this works. So Docker Container Run or Docker Run. Objective is to run this command uptime. It needs an environment. So we use, let's say Alpine 3.12. If again, images have defaults as well. So if you do not see this part, for example, you may just leave it out as well, in which case it's going to pick a default tag, which is latest. The default tag is latest. If you be explicit, it's going to use that, let's say 3.12 in this case. But if you leave it out, it would still pull the image, and it will pull the one with latest. So not providing this is equivalent to using latest. All right. So when you run Docker, when you run this command, let's find out what happens. And we're going to analyze the events in details. Let's look at the output first on the bottom side here. So it says unable to find an image. Now, if I had provided an image with 3.12, it would have shown the image is already there and it would have proceeded with the next command. But since it was not available, the latest version, remember each tag is a different version of the image. 3.12 may not be the same as latest. Latest may be different. So it's pulling that image. And after that, it shows me the output of this command called as uptime. Now, what actually happened on the backend? This is what you see on the client side. What happened on the server side? This is exactly what you see here. So it pulled the image, then it created the container, then it attached to it, then it attached the network, then it started the application or the container, and then it actually died and disconnected as well. Let me actually explain this using an illustration here. So these are the events. we're going to look at these events with this illustration actually. So what actually happened here? So we have a Docker host, which is running Docker daemon. And we use that Docker client to run this command. So Docker run, comes from the Docker client. And then it connects to a Docker daemon, and then it starts pulling the image first. Images are stored in the registry. Since it was not available locally, it pulls that image from the registry. That's the first event. Now, what happened after pulling the image? It then creates the container. When you say create a container, it's just the entity of container is created. It's like creating a VM, but not starting it. And then it creates a namespace. Everything is created right here, the namespaces and everything, but it does not actually start the application inside that container. That happens a little later. Once that is created, then the next event is Docker daemon attaches. This is important actually to understand. Docker attaches to the process. Why? Because Docker monitors. So Docker actually acts as a process monitor as well. Second is this is how it collects the logs from it, and we're going to look at that and then maybe forwards it somewhere and so on. So to manage the process, Docker always attaches to it, and that's what you should have seen in one of the events. So Docker container attach, that's what you see here. Next event is when it creates a network. Again, there was a question in the previous session that, can you attach a network and detach from a container? Yes, and that the reason for that is network is a separate entity. A network is created separately, a network namespace, a with interface, and it's created using a network pair of devices. And then that is attached to the container next. And then the actual application or the command, in this case, it was uptime, starts running inside the container. Right? So it opens up an execute shell actually, and then it starts running the command application, whatever it is. And then once it is done, till the command is running, right? I'm coming to that next actually, what happened to our container. So till the command is running, the container is alive. The moment the command exits, in our case, it's uptime, just one off command. So the moment it exits, it actually stops the container. So there is a die event and a disconnect event on the network side, and that is because, and that represents the stopped container. So network was connected, container started, then it died, and the network got disconnected because the container is stopped actually. When you say die, what happens actually? Let's find out. How do you list your existing running containers is using a command called as Docker PS. You could also use Docker container PS if you want to use the management command, the new way of doing it. But I would keep on using PS, which is simple as well as it's, I'm just used to it. I do not see any container running here. Let's find out what happened to our container. I'm going to use another option to it, that is -L. -L represents the last run container. This is the last run container, and I see it actually. And what do I see? I see the container ID. Container ID is this. Then the image it was launched with, the command. When was it created? What happened to it? The status says exited immediately. That was about 4 minutes ago, and there was a automated, auto-generated name for that container. So when it says exited, what that means is the container is stopped. Why is it stopped? And this is what we did to list the containers and find out what happened to it. Now, this is an important concept. And this also, is different than the VM, right? With VM, you can start an application, stop it. You can use, service start, service stop. Even if the application stops, your VM still runs, not with containers though. So Docker or the container will last only till the application is running inside it. The moment the application exits, container also exits. Why? Because, the right way of looking at container is nothing but a container. When you create it, it's nothing but an application running in a contained environment. The most important part here is the application. A container is nothing but an application running with all these namespaces, Cgroups, and nothing, all of that jazz. But the moment the application dies, there is no need for the system to keep running that container. The container dies, right? So container is nothing but an application running in a contained environment. That's an important aspect. Just remember, I'm emphasizing on that because that's where a lot of people get confused. And I'm just going to run a few more containers. So every time I use this Docker run command, you will notice that it's going to launch a new container, right? My container is in stop state. I can start it again. I can go and start that container too. Let's say Docker start and the container ID, but I'm not going to do that. I'm using the same image, but launching a few more containers, maybe with different commands now, just to try out. So I launched a few more containers. Every time you see the same events. So container was created. You don't see the image pull again because once the image has been pulled, it doesn't need to pull again. So it looks up always locally, and only if it does not find it, it pulls the image. That's why you don't see the pull event, but you see attach, connect, start. The same process followed because all of these have been one-off commands.
Hey, Gaurav, sorry to interrupt. Where these images will be stored?
All these images are stored. Okay, I'm on a Docker daemon on the same server as Docker daemon. So if you're trying it on your desktop and laptop, it will not work. You have to be inside the VM where the Docker is running. And if you are, you can actually see it in, I'm on a container. I'm inside a container. No, I'm not. Okay. Yeah, so all these images are here. So images are not stored. We've seen this earlier. Images are stored in the form of layers, and these are the layers. So Docker image ls, even though you see an image like this, image history is a very important command. You can provide the ID of the image. You can also provide the name of the image, which is latest. You can see that it's one of the layers, right? So A24 something. So you are going to find those layers actually being stored here. So images are stored in the form of layers, and the images are stored typically in this overlay to directory on the host, which is your Docker daemon. That's where the images are.
Okay.
Okay, so all of these, coming back to our original discussion, all of these are the hostname one-off commands, and just started the container. None of these are running persistently. So I don't see it in the running containers, but I do see it. Let's say there's a last run container, but if I want to see more, how do I do that? So how do I list more than one containers? Is using these commands. -l is the last run container. -n is going to give you how many, let's say -n2, last two. -a is all. And when you use these commands, it actually shows you all containers, whether it is running or not, it's going to show up. So let's try this out. That's the reason why I launched those many containers. So Docker ps -l is one, just last run, one container. -n and let's say three, last three. -n2, last two. Right? All of those exited. The commands were different. -a shows me all. Now, let me actually explain these fields. So when you display the list of containers, the first is the container ID. Container ID is actually, there's a long ID. This is the first 12 characters of the actual container ID. There's the image that you launched with, the command. When was it created? Create time. What is the current status? Port mapping, we're going to come to this later, and the name generated automatically. And this is typically a funny automatic name created with object, the objective and a noun. So I have a elated Jones and thirsty Jasmine and boring Borg and peaceful Shannon. If you don't like these names or if you don't want them, you can also provide a name while launching a container. So when I use run, I can always provide a name. And it gets created with that particular name. So you can provide a name. There are many options actually. Docker run -- help is something that I want you to explore further. There are tons of options, and this explains a lot of things that Docker can do or you can do while launching a container. That includes CPU quotas and the memory and health checks and stuff like that. There are many things. We're going to look at some of these, but it's just impossible to cover everything in one session. So Docker run -- help is something that I want you to explore further. We were listing the containers. So Docker ps -a -l -n. Those are the commands that you would typically use to list those containers. Now, all of these containers just came up and they were stopped immediately. We couldn't actually figure out what's happening inside that container. How do you do that is using, actually, you can launch a container with an application which is long running. That's number one. Number two is you'll have to use some options. What are those options? Let's look at those. And those are the -i and -t options. Again, very important options. What -i does is it lets you interact with the application, that is shell in this case. And that's the reason why we have started with shell. It can be your own application, let's say a Tomcat or an Nginx or anything else, a database. So that will be your application. And then it can let you interact, and then it allocates a TTY. So TTY, these generally go together. You don't use I and T independently. Typically, you'd use typically -i and T together. And it allocates a pseudo terminal. You need a pseudo terminal to connect to shell or to connect to anything. Even if you are using SSH, Telnet, you typically get a TTY. And that's to connect to the shell. So what are we doing now? We are using the same image. Same commands earlier. New options -i and T, you can run it together, and the new option is shell. So instead of one-off command, now it would be the shell that you would run. So Docker run or Docker container run is the same. So Docker run and Docker container run is exactly the same. You can use either, it doesn't matter. -it is what I'm going to use. Alpine, let's say this time I'll use 3.12 and a shell. Now, what you'll see interestingly here is this time you are going to see a different event, that is resize. You don't see die and disconnect, but it creates a container, attaches it, connects to it, starts it, and resized it. What is this resize event? Resize event is what creates the writable layer, read-write layer. We have spoken about the overlay file system. We've spoken about the the writable layer. The original image is mounted read-only, and to allow changes, it creates a writable layer. That's what gets created here. And what do I see here? I am inside a container shell, right? And I can actually run these commands. Where am I? I'm inside a container, and I can explore this a little further. Now, let me show you.
So Gaurav, is resize a COW, cow?
Copy and write is basically, yeah, so copy and write is involved. So when you talk about file system, your copy and write is involved by default. So it creates that writable layer. If you make changes to the existing file, it will get copied to that writable layer, and that's part of the copy and write. So file system wise, you have two concepts. One is the layer overlay file system, union mount. and then the copy and write. So both will be involved here. Yes. Let's find out what is namespace, what is not. So if you look at, I'm on the system, underlying system here, and underlying system is Ubuntu versus when I'm inside the container, I see Alpine. That's the file system namespace. We've spoken about this earlier. Process tree, I see a lot of process, the entire system process right here. That's my system view. This is my container view where I see only the process inside that container. It's a contained environment. It's a namespaced environment. Similarly, every container has its own network stack, IP address, routing tables, IP tables. You can define it for that container as well, versus the network stack on the host looks different. There's so many interfaces, and there's a mapping, right? So I've spoken about this. There's a V8 pair. So this interface maps to one of the interfaces here. Host name is different. So all of this is namespaced. All of this is isolated. But only these things are isolated. We're talking about operating system level virtualization because ultimately this process is running on the same system. So whatever the PID 13993 here is what you see here, right? Everything else though, apart from these five, six things really is shared. So you can see the kernel information is the same kernel. Uptime is not a container uptime. 34 days is my system uptime. Right, so CPU information is going to be same. You don't have virtual CPUs.
Hi, Gaurav. Sorry to bother you.
Yeah.
Well, the network will be changed every time because it goes through the process. So network will be detached. So whenever the container will be restarted, will it get a different network or it will be the same network?
You can actually associate a specific IP address and all this configuration to a container. So you can do that. So you can actually stick a network device or an interface to the same container in a sense, basically. So you can define IP addresses, you can define the same configuration. So even if you restart the machine, you would see the same network configurations on that container itself.
Okay, if I install Docker on my laptop using Windows, it will also have the same network because every time whenever a container will be restarted, whatever IP, the laptop will
you
have.
You can define an IP address as well when you create a container too. And even on Windows, it would be similar. The technology, underlying technology is different, but the behavior is same. Whether it is Linux or Windows. But if you do not see, I'm not a Windows expert, so if you do not see that on Windows, do post it in the Slack channel so that we are aware of that and we can debug it a little further, the behavior. Okay, so basically, not everything is isolated. A lot of things are just shared, including the date time. There is no time namespace yet. The memory, CPU. So basically, you have access to the same CPU underlying. You can still control the amount of CPU, but you're talking to the same CPU. It's not virtual CPU we are talking about here. Everything is controlled at the kernel level using namespaces and cgroups. Now, till the time I'm on the underlying system here, till the time let me actually watch this so that I can show you. Till the time I'm inside this shell, I launched the container with a shell, and till the time I'm inside, I still see that container running. The moment I exit, I can use exit as a command. I could also use Control D to exit from here. You will notice that the container went away. And that was because my application, the shell, exited. And I did not use a special option, which would have made it possible to keep running, to be persistent. And that special option is what we're going to talk about. The most important option that you use with the container is the -D. -D is the option that I would say is most of the containers when you want to launch and have them running in the background, you're going to use that -D option. Typically, I also recommend -INT. -INT is not a must, but using that is actually makes a lot of sense. I'll show you why. But -d is a must. And this time, actually, I'm going to launch a container with a different image and a different application called as program. The application name here, in my case, is program, and the image is this. In this case, I have, this is the namespace, field number 2. I do have it here. This is the repository. The tag is latest. The registry is Docker Hub. Since I don't, so when you look at an image, you should be able to identify all 4 components, even if they're not there. So the registry here, 100% is Docker Hub. The tag 100% is latest. This is the repository. This is the name, user, or a username, organization name, or a project name, that is. Now let me actually run this and show you what happens. On the top window, I will be watching the events again. So this time it would be docker run -idt. -d is the most important part here. This is the image with the application, which is program. Now to show you the importance of D, I'm going to eliminate this, remove it for now, and show you what happens. Again, it needs an image. So it pulls the image, creates a container, attaches to it, started it, resized it because it's running. Now, see, the problem here is I cannot go and run any other commands because I'm stuck with the process. It is attached to the process. You see that attach event. What happened is Docker attaches to the process. In this case, it's program. Program is just a script that I've written. It's an application inside it. So it is attached to this. And this is the output of that application. Whatever is sending on the standard out, you see it here. And I'm stuck with this output. Now, I still have some way to come out of it using a sequence that is Control-P, Control-Q. And this is possible only if that sequence, Control-P and Control-Q that I used. So you can see that on the right-hand side. This is without D. That's what we're doing. The Docker attaches to the application. And I used Control-P followed by Control-Q. It's not Control-PQ, it's Control-P followed by Control-Q. I could detach because I'm using -I and T options. If I don't use -I and T, this is what happens. Let's find out what happens now. Again, it's launched. Since I did not use -D, it is stuck. It is not detaching. It is attached to the process. And if I try using Control-P followed by Control-Q, does not work. The only thing that works now is Control-C, which kills the container. It comes out, yes, but it kills the container. I'll show you the difference. I launched the first container with -IT. I could come out gracefully, and that application is still running up for about a minute. The second one got killed because I had to use Control-C, Control-P and Q did not work. So -I and T, that is the significance. -I actually stands for standard in. By default, Docker attaches to the standard out and standard error of your application. And this gives you a standard in, right? And -D does this actually. -D will detach. So at the time of launching it, the sequence of these options does not matter. DIT, TID, TID, whatever, you can use in any sequence. So when you use -D, it detaches from that application, from that container, and comes back on the shell. And the application keeps running. That's the important part. Still running. And this is the default option that you use. -D stands for detach, but you can also say it's a default. So what is the default option? -D. It's in -D right there. So when you do -D, it by default runs the container, runs the application, and it runs in the background, and it comes out. It's in a detached mode. And that's the option that you would typically always use. Now, I have this container running. How do I go back to the shell of that container? When I used -IT, I could do that, but now I have this -IDT, the container is running. What if I want to debug this container? What if I want to troubleshoot it? What if I want to go inside it and make changes, maybe install some application inside it? So we're going to look at all these situations. So I'm going to give you 3 scenarios that we look at here. The scenario number 1 is, let's say you have an application running which is not working. It has a problem. How do you troubleshoot it, right? Generally, the first thing that you look at when the application fails and container fails is the logs. Are the logs? How do you check the logs? We'll look at that first. The second thing that we would look at is, all right, so logs don't show me much, or I want to get inside, get to the shell of that container, and that is where you would learn how to use this Docker exec. And the scenario number 3 is, let's say you have a container running, or you want to use container instead of a VM, a development environment, and that has a base image, let's say Ubuntu version of something, and you want to make changes. You want to install application, and you want to do something inside that. So let's look at each of these scenarios in details. Scenario number 1 will troubleshoot the issue or learn to do that by checking logs. Scenario number 2 is we'll learn how to connect to it, just like an SSH connection. And scenario number 3 is just the extension of this. We connect to it and then we install something. This is also, how you can use your container as a dev environment. Let's, explore each one of this. All right, so I have a container whose, right, let me check. Yeah, this is the name of the container. I am just going to rename this to loop. You can always rename. A container on the fly using, instead of, either you can use, when you reference a container, you can either use this, or my favorite actually is using a glob. Just first 3 characters. Typically, first 3 characters are unique. If it is unique, it's just going to work. In this case, it's just 2 containers, so first 2 will be unique. So I can also refer to that container as 8B, just 8B, easy. And let's look at, okay, I'm renaming this container, and I have to provide the name. Yeah, you can see the events every time. So that Docker system events command is actually very, very useful. Okay, now I want to check the logs. This time I would use the name of the container, that is loop. Instead of the ID, I would use the name. So Docker logs and ID or the name, loop. I see the logs here. Now, if I want to follow the logs, just like tail -f that you use on a log file, I could use -f for follow. Now, what happens when you start following? You are attached to the log file, and whenever the log file updates, you see it immediately. So this application actually just prints this line and sleeps for 4 seconds. So every 4 seconds, you see that log being updated. Yeah, this is how you check the logs. So if you want to find out the, if the issue with the applications, typically you are going to use Docker logs -f. This is the name of the container. Now, how does it actually know about the application logs? Let's find out. Let's actually look at how Docker manages the logs. Again, a very interesting concept here. So you might remember that event where Docker attaches to the application. That is important here. So when you launch a container, and let's say you have an application running inside it, your Docker daemon actually attaches. One of the event was that attaches to the container, to the application itself, actually. Now, what is the significance of it? One is Docker knows if the application is not running, and it can restart that if you have a restart policy defined. The second use is it also collects the log. It is attached to what? It is attached to the standard out and standard error of this application by default. So your application is supposed to, ideal case is this. We're talking about ideal case here. We'll talk about the real world applications later as well. So If your application supports it, if your application is sending everything to the standard out, which is a best practice, Docker knows how to pull that out. And then what does it do with that log? Now that depends on the log driver. The default being JSON. This is the default, but Docker is actually capable of forwarding your logs out to multiple systems. Let's say Splunk, AWS logs, fluently. You might have to add some configuration, but this is absolutely possible. Now, how do you find out the log drivers? Is you can actually go to the Docker system info and look at the plugins and logs. Let me demonstrate this to you. So as I mentioned, Docker system info, we would be going back to it over and over again. So here you see plugins, and one of that is logs. So Docker by default supports all of these log drivers. The default being JSON. How do you know? It's there. Logging driver, the default is JSON file. Now, what if I want to use something else like Splunk, AWS logs? Let's find out how that works. Okay, we're looking at Docker logging drivers documentation. This is the official documentation from Docker's site. And you can see that it supports all of these. Default being JSON. It says here default logging driver is JSON. And it supports all of these as well. Let's say we want to use Splunk. How does this work is you have to provide options with Docker run command. That's the reason I mentioned to you, Docker run is extremely powerful. Go back and read about it definitely. If you are going to use Splunk, for example, you have these many options because you have to define the credentials, you have to define where your Splunk server is, you have to define maybe some tags and how you want to, where you want to store those logs with what categories and stuff. So your Docker run actually becomes like this. If you start using log driver as Splunk, it's going to look like this, and with all these log options, which could include Splunk token, authentication, Splunk URL, the certifications, the tags, labels, environments, any option that your log driver needs. And this is how you can use a different driver than JSON. Right now, it's the JSON file. How do you find that out? Is I'm going to go to and show you, there's a command called as Docker inspect. That's another important command. By the way, when I say this is a container ID, this is just the first 12 characters of the container ID. The actual container ID you will actually find out with Docker inspect. So Docker inspect is another important command. It gives you every single information about your container. And when I run Docker inspect, first of all, let me show you the container ID. This is the first 12 characters of this entire ID, right? You can also find out where the log path is here. You can find out what application is launched. Are there any configurations? What is the network configuration? Every single thing here for that container can be fetched from this. You can also use a template to fetch just a specific field from this output. For example, log path. Where is log path? Here. Where should you be looking at? Not on your desktop, not on your Mac or Windows. It is not going to work. You have to be inside the VM or the Linux environment to see this. I am already on a remote Linux Ubuntu machine where Docker is running, and I can see that JSON file. So the output, actual output is this. The JSON format is this. Generally, you have a log level, the timestamp, which stream is it? There are 3 streams: standard out, standard in, error, standard error. You should know about those are the fundamentals of Linux actually. So you should know about those 3 streams, and it's pulling it from the standard out. This is the timestamp so that you can forward it to some time series monitoring system like Prometheus and stuff. This is how Docker, this is the ideal case actually, how Docker log manages the logs. Now, what about the applications which cannot? In this, the key here is your application knows how to send the logs to the standard out. That is the assumption. And based on the assumption, this will work. This is the ideal case. What if your application is writing to a file, var log XYZ? A lot of our applications do. Or if your application has multiple log streams, what do you do in that case? Let's look at this in the next illustration here. So what happens if this is the assumption, right? So Docker attaches to the application and then it uses one of these drivers. Now, what if this is the assumption? What if this is not true? What if you're writing to a log path? So the option number 2 is, and what you do is basically create a volume. There are ways to create volumes, either a local volume, a network volume, whatever it is. And then you mount that volume inside the container. Create a volume, mount it inside the container. To which part? To, let's say, var log XYZ. So that whatever your application is writing to is actually going to this volume. Now, okay. Right, so this is sort of the non-ideal way of doing it, but this works, if your application does not support writing to the standard out. Now, the point I wanted to mention, which I had forgotten, but now I remember, is why not store the logs inside the container? Why store it in the volume? The answer to that is in the overlay file system. Again, it goes back to our basics. So that's why it's important to build those foundation with file system overlay. You need to understand that because the containers are created with ephemeral file system. Yes, you have a writable layer, but that writable layer is also ephemeral. If you delete the container, it goes away. You have to commit that, and you have to create an image, and you have to keep on doing that. Well, storing the logs as part of your image makes no sense. It doesn't make sense at all. And then, especially if you talk about Docker deployments in production, they're immutable. Your containers will come and go. And every change will lead to replacing those containers. So what do you do? How do you manage the logs then? You store it outside the container. So in no situation, and this is the best practice, in no situation should you be writing the logs inside the container. That's a strict no, because your logs will go away the moment the container gets deleted. And that happens a lot in a production-like environment. If you are just doing it as a test run with just Docker, it doesn't matter. In which case, it's still okay, I would say. But in production-like environment, you definitely need something like this, a volume, or and then from here, you will have to use forwarders because Docker is not forwarding this volume by default. So you'll have to have another application which collects this data and let's say send it to Splunk, like Splunk forwarder, HTTP forwarder, or something like that. And that is how you manage the logs, right? This is an important concept. There are ideal situation is when your application sends it to the standard out, Docker picks it up, stores it as a JSON or forwards it. Non-ideal situation is you're writing logs to some path and you write it to a volume, and from there you manage or you create a system that manages these logs and sends it to a centralized log management system such as ELK, Splunk, and so on. All right. Let's move on. But before that, let's take a few questions if you have any related to the log management and anything that we've covered so far. If you have questions, just go and shoot, and I would start answering them.
Gaurav, Santosh here.
Go ahead.
Gaurav, I'm using Docker as only for repository and Kubernetes as a containerization engine. I'm facing the same issue I'm facing every time, like with the Docker purging policies. So sometimes by default, I am instead of deleting the log file, I have deleted the container and everything is get washed, and from beginning I have a start. So what do you suggest in this case? How will in my case how will set the purging policy of this Docker log?
So if I understand correctly, you are using Kubernetes, and in the Kubernetes, your logs are being lost because the container gets deleted. Is that the question?
Correct.
Yeah. So you should be managing the logs using one of the systems, such as either store it in a volume, or you can basically have some agents which run on every node. which collect the log from a specific path. Typically, a container, it's not a direct way of doing it, but that's how you have to do it in Kubernetes is basically, you may have a lot of containers. So ultimately, what is Kubernetes? Kubernetes is just an orchestration engine. So inside Kubernetes, you're going to have nodes. Inside those nodes, you're going to have your containers. So when you have those containers, let's say on one of the nodes, ultimately what they run with is Docker. And then Docker has a path, and you have to take it from that path and have a forwarder that's running as another application, another container on every node. There is a concept called as daemon set. In Kubernetes, you run your forwarders as daemon set so that you run only one on every node. You collect it.
Sorry,
and then
sorry, Gaurav. I implement ELK for this. This is not a question of Kubernetes. Kubernetes, like I have the ELK kind of. I have given amount path that and everything. I'm talking about every of Docker.
Santosh, your voice is actually breaking. So Santosh, your voice is breaking, and I'm not able, this might need some more time. So we can take it on Slack, and I could answer it there because we have a limited.
Hello, Gaurav. Hello.
I'll take the next question. Santosh, we'll come to the question. Please post it in the Slack in detail.
Hello.
Go ahead, Ayush.
Sure. No problem.
So Gaurav, my question is: so you are saying that suppose if you are writing an application, then you have to take you have to save your logs in a volume on your Docker host, so that it will not be a problem if your container get lost during some means because of some issue in their application or your Docker host, means whatever happened, right?
Mm-hmm. Yes.
So actually, I have created the same scenario. I have just installed the Jenkins over the Docker container and saved the logs in a local volume. Means
okay.
So, but what happened whenever I installing means I just delete that same container, and my question is if there are 2 or 3 container running with the same OS image on that container, and we are saving the logs in the same volume, then it will be a problem now. So
it will be a problem. Yes. So you have to, so either you have to use different volumes, or you have to design a way in which you can configure your containers application to write it with some path. So let's say var log Jenkins, but with a container ID, and that is a directory inside that you write the volume. So you'll have to design that separately. Again, ideal case, Jenkins log can go to Docker directly over the standard out. Volume is the second case. It's not an ideal case scenario. You should try to use the first scenario always, where you send it to standard out. If that doesn't work, only then you are considering the second option where you're writing to volumes. So you have 2 options. One is follow the first path. Second is you create a way so that your logs are unique in a unique directory. Same path, var log Jenkins, but maybe with host name or something. There is a way to configure your applications or your log paths in the application, so you can use that. So you'll have to create that way.
Okay, thank you.
Okay, Gaurav, I have one question.
Go ahead.
Yeah. So what I have done is I have installed Docker on desktop, my Windows desktop, and the thing is that while I'm working on Jenkins and the other stuff, it is getting the performance is getting deteriorated. It is getting slow. So what I want to understand, should I move to cloud itself, or on the like on the desktop Docker itself on the Windows?
Okay, so can you repeat the question? What is hitting their performance actually?
So what happened that in the morning while I was working with the Jenkins, I was creating builds. Okay. So what happened that I did it 3-4 times and the whole system hanged.
Just check your configuration. Mainly, if it is a Jenkins, there is a configuration for the number of builds that you can run in parallel. Keep it limited and play around with that configuration. It's a purely Jenkins configuration. Jenkins is trying to consume a lot of CPU. That's what I assume. Second is you can limit the CPU. I'm going to show you how in a little bit. you can try controlling the resources also.
Okay. And one more thing, if I have to deploy an application, let's say web application, the best would be cloud, right? It would not be a Windows desktop like Docker desktop.
It depends. I mean, if you have a powerful enough system, you can do that. Or if you're playing around with it, but ultimately you may want to move to the cloud and just deploy it there for a couple of reasons. One is it is always on. I'm not sure what kind of application we're talking about and what kind of environment it really are talking about. But for development, a Windows machine, Mac machine is typically useful. Only if you have a problem with it, or if cloud gives you more advantage, move to it. That's what I would say. But there is no reason for the Windows machine not working.
Thank you.
Next question, Rajsekhar, you can go ahead. You have raised the hand.
Yeah. See, we are talking about Docker Daemon and Docker client, right? So what are the ports involved in here? On which port this?
We are talking about port mapping next, so I'll answer that in a due time.
Gaurav, one last question. Like, it is in connection with volumes creation. Like, if the container is running in production, like until and unless the application inside the Docker container is alive, the Docker container will be in a running state. It doesn't get exit. So the logs will definitely be there in the JSON format. Why do we need to go for volume creation in spite of keeping it in a default state?
Why need volume instead of writing it to the container itself is the question?
Yeah, absolutely, for
Because
production.
if you lose the container, and you would very often, because every time you have a change, it gets okay, I'm gonna mute. Every time there is a change, you replace the containers. We're talking about immutable deployments. Immutable deployments are basically you will not have the same container running forever. Unlike our servers or the VMs where we go and update the same application, same VM, it doesn't work that way in Kubernetes or a production environment. So it makes sense. If you want the logs to persist, the answer is you need a volume, or you need the system that we spoke about in production.
Gaurav.
So you mean to say that whenever there is a writable layer coming inside the Docker container, so that the initial container will exit and a new container will get generated?
Yeah, so unless you commit those changes, so the writable layer needs to be committed, and only then it becomes persistent. And when you commit it, it becomes persistent in the form of an image. Now you don't need your logs in images at all. So it's definitely not a good idea to write the logs to that overlay file system. You keep it always separate than the container is. Okay, so I'm going to stop taking questions right now. We're going to come back later, I promise, but we need to move on and talk about at least a few more things, right? Some of the important concepts that are going to answer some of the questions which have been asked already. Let's actually look at the second part, which is very important apart from logs. So first scenario was I want to debug the application. That's logs. Now, if that doesn't work, how do you actually, it's a lot of times you use the SSH to get inside a container and work with it and so on. So equivalent of SSH connection in Docker, because we're talking about Docker, so Docker takes an opinionated approach. What that means is you use Docker specific concepts. We use exec and then let's say container ID. And if I just want to run one command, I can do it this way. But most common thing that you do with exec is exec-it. Do write this command down. This is very important. And then a shell inside the container. It could be sh, it could be bash, depending on the system that you have. And now I'm inside and you can see that it actually opens up a new shell. The shell is a new program. This is my original application. It opens up for one more command, one more application, and I'm in with that shell now. And then I can do whatever I want inside this, install applications, this is this is Alpine, so it uses different commands, APK and stuff like that. So, but you can make changes. You can do whatever you want. You can install applications, troubleshoot, see what's happening, troubleshoot networking issues if needed. But I think this is something you will need to do a lot of times, and you must know the exec command with the options exec-it, the container name, and a shell. That's sort of very, very important. from the troubleshooting point of view. Again, if you want to modify something, you can still do that using a similar approach. So this time I would use, actually, this time I'm going to use something interesting. So I'm using Docker run -it, not D, because I want to connect to the shell on, okay, a system. I'll give it a name called as Redis. I'm using an image which is Ubuntu, and I'm opening it with a bash. Why bash? Why not sh? Because I used sh with Alpine image because it only has sh. But if you have bash, you're free to use that as well. And I'm going to do this now. And in fact, I'm going to add one more option. I can delete this container using this command. We'll talk about it a little later. So I would be using -rm. Now, what is the significance of -rm? It will, when you stop a container, it will automatically delete that. That is the significance of using -rm. And once I'm in, it's a Ubuntu machine. I can, let's say I want to install an application inside it, or I want to use it as a dev environment. You're free to do that. And the changes that you're making right now are persistent till the container exists. So you can actually use it as a dev environment, make changes, go back, stop your machine, restart it. Even if you restart the container, your changes do not go away. I'll prove that point here. I'm going to install Redis. It has this application called as Redis. I'll just install that.
Gaurav, one suggestion. The first line is not visible because we have a Zoom and then you have a recording and all the stuff. So maybe you want to start.
Okay, I will note that and use the second line onwards when I run the command. Okay, Redis is installed and I can launch it this way. That's it. So I have an application installed. So I took the base image, added my application. I can also commit this and create an image with Redis, right? That's the simplest way of creating an image as well. And I have this application running. It's so quick, actually. So this was an example of the third scenario where you could actually go to a container, modify it, and then when you come out, it doesn't go away. You can stop that container very well. Okay, Docker. Oh, I had used -rm option, I think. Yeah, so that's sort of a downside of that. But you could, I'll show you another one. Docker stop this container. So if you have made any changes, when you stop it, you can also bring it back. If you are going to use it as a dev environment and use it for a longer time, don't use -rm option because it will delete it immediately after you stop it. But if you have stopped the container, you can always start it back and it will just come back up again. So it's been up for 6 seconds. And any changes that you made are still there. You can go back. You can, you'll see all your files, anything you added, in anything that you changed, anything that you installed, already being there, right? So next concept is about port mapping. And this time, so far we've been using this mock application. This time I'm going to use.
Gaurav, sorry to disturb you. I have a question. So if I delete the means I stop the container and after that I delete the image, then I will not be able to start that container, no?
You cannot delete an image when there is a container created with that. Until you remove the container, there is no way you can delete the image. You can actually.
Also.
Yeah.
Okay.
So this is the image. Let's say we are using this image. If I try to remove this image, it's going to show that error. This is being referenced in multiple repositories, unable to delete, and so on, must be forced. So you cannot or should not delete this image at all while the container is running. You delete containers, which is different, but images are generally, you don't delete those unless it is sort of, there is a reason for it, or you're cleaning up with no containers running, that is. Now let's run it with a new option, -p. Docker run -idt. I'm using -p. Do note down this has two fields, left hand side, right hand side. This time I'm going to use a new image. I won't use any application. So far we've been providing the application commands. If I do not provide it, it picks up the application or the command from the image. The image has it. Docker image history, very useful command. Right, so the application is given here, CMD. So images have metadata. So even if I don't provide the command, it knows where to pick from. And then it has done some port mapping stuff here. Let's find out what it actually did. So you see a new option here, which is 8000 to 80. Now, what is this? Let's interpret it and let's understand what actually happened here when I run this command. So when I use this option, what happens is, let's say I have a container running an application. My application is running on port 80. So what you see on the right-hand side of that equation is the actual application port. Now, my container actually gets a private IP. And that private IP might be, default is generally 172 something. So generally, you cannot access the application, this one, using this IP if you're trying to come from outside, right? And this is why you need to create this mapping. So with the mapping, what you do is, let's say I'm sitting outside, I can access this host using the host's IP. Let's say 10.0.0.5 here. And then what I do is, if I want to access from outside, I open up a port on the host side, this one, and this port then redirects me to the actual container, right? So the host side port is what you see on the left-hand side here. And this port, right-hand side, is the container port. This is what happens here. And that's what you see when you see this output. So on the host side, I have 8000, which is pointing to containers 80 port. If I want to access it, if you're using Docker desktop, you can just use localhost and let's say host port, left-hand side, 8000. I'm using a remote server, which has a public IP. So I have to use the IP address :8000. And what happens here is it actually takes me to the container IP. So I'm using this 8000 IP, and that takes me or forwards me to the actual containers IP, because that is how this port mapping has been configured. And that's how I see this application. I can prove that this is the application because I can stop this container. And when I stop this container, if I refresh, this should go away. You're just gonna see an error. It is trying to load, it will read timeout at some point of time. Eventually it will. Now, in the meanwhile, I will show you where is this configured. So the port mappings are done using just IP tables. It's all in the kernel. The answer to everything that you typically see, all the magic that you see around Docker and even Kubernetes, a lot of that comes from the kernel. So let's find out which rule is it. I have a port mapping which says 8000.
I think you have stopped the container. That's why.
Oh yeah, that's probably why. You're right. So what I was showing you is goes away application. When I start it back, I should see that. Perfect. Yeah, that was the reason. And you can see that IP table rule here, destination NAT. So the port 8000 is pointing to this container. This is my application container. This is the IP address of internal IP of this container. I can find out using Docker inspect. And that's the IP of the container, right? So all of this happens via IP table routes. So Docker takes those commands, let's say Docker run -p option and stuff, and then it translates into something that the kernel does, and that's how this actually works. You can also find out the port mapping using Docker port command. Now, actually, there are 3 ways to port map. The one I showed you is the first option that you see here, where you have a left-hand side and the right-hand side with small p option. Left-hand side is host port, right-hand side is container port. Now, you can also use capital P. When you use capital P, there's something else happens actually. Let's find out. So this time I run a container. Okay. With capital P. No ports defined. That's the important part. Docker PS -n2. This one I use the port mapping 8080. Even in this case, actually it has picked up the right-hand side, which is the container port automatically, right? And then it has done this as well. So it has actually mapped some port on the host side, which is 32768. In fact, if I run this again with capital P, I run 2 more. Every time I use that capital P option, it auto increments this port 771, 772, 773. So if I go to any of these ports on my host, I should see this same. The container ID is different. So this is 772, 771 is a different container, right? So how did it do this, right? So I just provided -p option. Now, first of all, how did it know about the container port? Just like command, Docker, it's in the image. Image contains metadata, specifically a expose instruction. Now, where does this meta come from? What makes up each of this layer? How to control that? We are going to look at in the next session. That is about building these images. And when you build the images, you can define this metadata. You have a control over that. Since the metadata exists, it automatically picked up that port. And then on the host side, it starts with this range, which begins with 32768 onwards. And this actually is a system configuration. There's a system file where the port range is configured for non-default, higher port range. And that starts from 32768.
Is it the emperor ports, I think?
What's that?
There are some emperor ports now, which generally application don't use.
Exactly. So the unused, unprivileged ports is what we're talking about, yes. And there is a configuration file on a system where you see this defined. I actually want you to find this out. So how can, this is possible. It's possible to change this configuration 32768 to something else. See if you can figure that out. Let's say I want you to change this to 15,000. See if you can start from 15,000. There is a system configuration. Try to figure this out. That's another exercise for you. The third part is again small p, but okay. All right. This is wrong. This not wrong actually. I need to go back and show you from here. Yeah, so the third option is like this. So just small p and 8080 or something like that. So this actually is what do you think this is? This is a container port or a host port? If I just provide -p 8080, just type it in the chat window. What do you think? It's container or a host port? Let's find out. Host container 50, 50, 50, 50. Okay, this is actually a container port. Now what happens to the host port? Host port, Docker does it automatically. We've seen that. So this actually is equivalent to, and that's why you see those ports is this. This is actually the right-hand side, the container port. And then left-hand side is automatically taken by Docker. Now, when do you use this? Let me actually show you how this works. You can also use a combination. So when I run this container, I can use capital P, which exposes my 80 port. And then let's say I have an application which exposes 2 ports. My image has already exposed only 80. How do I expose the second port? I can use small p and let's say the port number. What happens now? It exposes 2 ports. Docker ps-l. Yeah. 80 is exposed, default, and then 443. That's the second port. It automatically did that. So if you want to expose additional ports, that's case number 1. Second use case would be you may not have an image which has the port defined in the metadata, in which case it is mandatory for you to provide it. So one way to do that is using just small p and the port number. These are the 3 ways to define the port mapping. Again, very useful. I'm going to share the entire, whatever you see as the class notes, and along with that, there's the lab guide. So it's coming to you. So you don't, even if you don't take the notes right now, you will receive it. Renaming the container, I have shown you. Inspecting the container, again, I've shown you this. So Docker inspect or Docker container inspect, if you want to be more specific, does that for you. Copying files, I'll just show you this. So we've spoken about that writable layer, read, write, overlay file system. Let's say, all right. I want to copy some files to this app, this container. I'll show you by displaying the files right now. So this is the diff between the actual image and after the application was launched, whatever changed. Why you see this changes is because it's a Python application. It generates this, it's an interpreted application. So it generates these PYC files and the actual application. So you see all of those directories and stuff like that. That's why you see these many files changed. C is for changed, A is for added. Now I'm going to create a file and add to it. I'm creating a file locally and I'm using Docker CP test file. And when I want to, it's like SCP. When you want to copy it to a container, you define the container name or the ID and then provide the path, let's say /temp. If I use Docker diff, now I see my file being added. Simple. You can also copy back from the container.
What is that /tmp?
What's that?
What is that when you are writing the command docker cp test file, after the container ID, that /tmp, sorry, I missed that.
Just a path. It's a path inside the container. Inside the container, it gets added to here. Let's say I want to add it to user local bin inside the container's file system. We're copying from the host to the container. So if I want to copy it to this, I would use this path. This is the path relative or inside the container. This is the path on my current machine, which is my laptop, which is my workstation. This is the client machine. And then I'm copying from client to the container. Similarly, you can copy back from the container to the client machine by reversing the path. The source becomes the container, and let's say /app, because you see that there are some files here, and you want to copy it to the current path, local directory, right here. And I see that app directory. So I copied this file from inside the container directly to my client machine. Even if your server is remote, this works seamlessly. All right, so this is how you typically copy files from the host, from the client to the container. Copy to it, copy from it. The /temp path was here, inside this container. All right. Okay, this is where you actually see Cgroups in action. So we've spoken about Cgroups theoretically, right? So Cgroups allow you to limit resources. So how do you actually do that? Is the interface is Docker. The Docker client gives you the interface, and it's really very, very easy. Let me actually show you this one by providing. So Docker actually does 2 things. One is it also monitors So Docker stats command shows you the monitoring data for what? For CPU, memory, block IO, or the disk, and network. CPU, memory, disk, and network. Those are the four things that you can control. Those are the four things you can collect the data from using Cgroups. So Docker stats is just an interface on the Cgroups that the kernel has. And now, if you look at the CPU memory, if you look at memory, look at the limit part. If you observe the limit part, it really doesn't have any limit. It shows me the entire RAM on my system, which is about 4 gigs, 3.85 something. Now, how do you actually put a hard limit on a container? We're sharing the same memory, same CPU. How do you limit that? Is using the Docker options with the Docker run command, or if it is a running container, you can update that container using Docker update command. Docker update, Docker container update, either of that. What are the things that you can change? You can change these many. Will be very specific to memory and CPU. Let's say Docker. All right. Update. And what I'm updating, memory. To, let's say I'm going to put a limit of 400 MB. Actually, there is one more thing that you have to do with memory, that is defining the swap memory, and then define the container name. Let's say I have a container whose name is loop. Yeah, if you look at that loop, I think it's 1, 2, 3, 4, fourth line, fourth row. Do you see it? Okay, let me start the stats again. Yeah, you can see that right there, the second column from the bottom, second row from the bottom. You see that limit of 400 MB. You can change that limit to anything for any of the container. Let's say 0C, the first container, the first row, change it to 400 again. Now this is a hard limit. This container cannot go beyond that. What happens if you cross that? Typically, there are two limits, soft limit and hard limit. Hard limit, if you cross it, there is a chance that whenever the application or system is running out of memory, it is going to kill that. That is an out of memory killer. Your application also will slow down because it's like having a limit, a physical limit on a on a CPU or memory, and it's almost similar to that. That is a memory limit, which is straightforward. You just define it in the form of memory, MB, GB, and so on, right? So that's the unit that you see there. CPU, on the other hand, has many different things, many different ways you can define this limit with, right? I'm going to talk about CPU shares. CPU shares, by default, kernel does fair scheduling, meaning if you have 4 containers asking for 100% of the CPU, each one will get 25%. That is the fair scheduling. But you can influence that different ways. You can define a specific limit of CPU that you want for a particular container, or you can define it based on shares, like you get X amount of CPU based on the total CPU available and who else is there. I'm going to talk about that. And that actually is very similar to nice values in Linux. So if you know about nice values are also for prioritizing your processes on Linux. That is sort of a predecessor to the CPU shares and stuff. And nice values typically range from +19 to -20. And +19 is actually lowest. -20 is highest. So if you can re-nice a process, there is a, if you re-nice a process, and let's say if you define it to have a value of -5, it's going to take, default is 0. So it is going to take higher priority than every other process which is running with default value, and so on. So if you have a low priority value, you can actually keep it, keep it there, and so on. Where is this useful? One example I can tell you related to CPU shares is, let's say Google has 2 different types of jobs typically. One is high priority jobs, which are search. Search, you need to see results immediately. Versus your indexing can happen in the background. It can be a low priority process as well. So Google typically, defines 2 different priority classes for it. And based on higher priority, or search gets higher priority, indexing gets lower priority, and so on. So you can define or leverage these methods and techniques there actually to prioritize your process. So in case of CPU shares, I'm just showing you a demonstration of this. So CPU shares, what happens is, just like the nice values, every container gets a CPU share of 1024. Every container will get that. And that, think of it as 1x, right? Because it's a relative value. By 1024 doesn't mean one core or none of that. It means nothing unless it is relative to something. So if you define another value, let's say 512, if this container with 1024 is going to get 1x amount of CPU, I'm going to demonstrate with an example so that it will be clear. The one with 512 will get half, and so on. So whoever has a higher priority gets more CPU. Let's look at the demonstration of it so that you actually understand this. Let's look at the fair scheduling first. So when I run any container, this time I'm going to launch. So if you look at the CPU, none of our applications are using much of CPU. So I have a load testing or a stress test application. It's called a stress. It's a Linux application, and I'm going to define however many CPUs you have. Accordingly, it will run the stress test or a benchmarking against it. So I'm going to use Docker run -- CPU shares. I'll just be more explicit. By default, this is the value. And then I have an image called as stress test with an application called as stress. And I define CPUs. So this is the configuration for this benchmarking application. How many CPUs I have? I have 2 cores. So let's find out what happens now. Okay, something I missed.
You missed a yes letter in the stress test.
Yes, that's right. Silly typos. All right. So first time it will pull the image, and I am going to launch 3 or 4 of these. So you can see that immediately, you see, observe on the top, the last row, it's consuming about 198, 196% of CPU. Why more than 100%? Because this depends on the number of cores. So 2 cores is equivalent to 200%. Okay, and I should have started it with -IDT. This is why you need those options, because now, first of all, I'll have to kill this container, which may take some time. All right. It's still running, that's fine. I'll run a couple more. Run this time with -IDT.
Hey,
Yeah.
Gaurav.
Yes, go ahead.
Real quick question. I see some of these options, like say, well, you should have run with that IT option or IDT. Is there any way we can make some of these commonly used option as a default, so we don't have to kind of trust the memory? Sometimes we do quickly run multiple commands, and we can kind of tend to forget
the quickest, easiest way to do that is create a Unix alias. So you use Docker run or just create a command which has an aliases to, let's say, Docker run -IDT. Right?
I see. Okay, so just use alias command. Okay, I got it.
Yeah,
that makes sense.
So these things can be done with aliases generally. Okay. So all right. So here you see the fair scheduling, 50% each, almost, right? Now we'll actually experiment with the CPU shares. Now I will provide the shares which are half of this amount, 1024. Now we talk about relativity, 512. If I say 512, one thing is you're going to see that every time I ask for CPU, it gets readjusted. The entire 200 slot gets readjusted based on how many containers are there. This is just prioritizing. We're not defining explicitly how many. And the last ones, you see that half the remaining, because this is started with 512. Or if I start with 256, it's going to take half of that, 1/4 of the original. So now you see about 40, 20, and 10. And if I have really high value, let's start with 4096, 4x of the original. Now this is going to get a lot of CPU, about 90%. My 1x is 220. Half of that is 10. The half of that is 5. And the 4x now, the one we started with 4096, is the last one, last row. This is how you can define, one way to define the scheduling. And typically in Kubernetes world, you actually define absolute number. So instead of CPU shares, what else can you do? Let's say Docker run --help. You can see all these options which are related to CPU. Yeah, you can define CPU shares, which is just one of that. But you can also define CPUs. Let's say in Kubernetes, we define in milli CPUs, actually, milli cores. Here, there is no milli core, so I'm going to say 20% using this. So now I should get about 20% of the CPU, absolute number. You can see that the last row is getting 20% of the CPU. So you can define the CPUs, and this puts the limit on the amount of CPU that I can use. If I remove that limit, it can go up to 100% also. I mean, by default, CPU does a fair scheduling, but yes, technically, if I have just one container running, it can take the entire 100% or 200% in this case of the CPUs. And these are the options that you can possibly use. And this is basically implementation of Cgroups. Docker has just a wrapper on top of that. And when you use these commands, it actually leverages that. Okay, there's just a couple more things that we're going to talk about are the containers lifecycle. So we've looked at most of the common options. How do you run containers? Typically -IDT. Port mapping is the 3 ways to do that is I've just explained with capital P and small p options. Exec and logs, very, very important commands those are, right? So apart from that, what else you should know about is just, how do you stop the containers? What happens when you stop the container? What are the lifecycle events of a container in general? And that is exactly what we would look at right now. So what happens when you launch a container? So you take an image and you use Docker run command. Run is actually a combination of create and start, 2 different commands and 2 different events which represent that. So container is created, and then you can actually individually use create and start commands also. In my lab, I already have that. So you can actually try creating a container and then starting it. Sometimes it is actually very useful. Now, once you have the container running, it goes in a running state, actually, once it is started. You can actually stop that container also. We're talking about Docker specifically. With Kubernetes, there is no way to stop a container or a pod in Kubernetes world. You restart, or you basically delete and replace. But with Docker, you can treat it as a VM or an environment like that. And then you can stop a container, you can start it back. Anytime you stop a container, you can always start it back. When you start it again, you do not lose any data. You can also freeze a container. Freezing a container just takes the CPU out of it. So it's as good as stop, but it is not the same because if it has anything in the memory, it is still there. It's consuming in the memory, but it's frozen in the time. I'll show you. I'll show you how to freeze a container. This is very interesting. Docker, right? There are a couple of commands here.
Is it like Hibernate?
Yes, sort of.
Or pause, I think.
Pause and unpause, yeah. So Docker container pause, and let's say 86. The last one. Observe what happens. CPU is gone. Memory is still consumed. So it is using 812 KB of memory, but the CPU is not receiving any CPU. So it is paused, and it actually goes in the pause state, which you can see from here. Docker ps-l. Yep, it's paused. And the moment I unpause, it starts running from the moment it was processing. How does this work? It's in the kernel. Kernel has a freezer. This concept of Cgroups and freezing and all of that, right? So it's all in the kernel.
So when it's paused, can you copy in and out of it?
Yes, you can. Okay, I've not tried it, so let's actually try.
I think we can not.
Let's try. So Docker CP, I have a test file right here, and then I'm trying to copy it to 86. I'll copy it to /temp. Let's find out what happens. Yeah, you can. In fact, I remember now. In fact, you can also copy a file to a container which is created and not running. In fact, on a Windows, that becomes a very, very useful. Recently, I've been trying out some Windows stuff as well. So you create a container, you copy over the file that you need, and then you start it. Because I remember why. Because if you're using Hyper-V containers, it is not possible to copy files while the container is running. So you have to stop it anyways. So even if the container is in the stopped state, you can still copy the file, which is really interesting. All right, that's the lifecycle event. We looked at the stopped container, which can be started. And then when you use Docker RM, that's when the container gets deleted. Once the container gets deleted, though, you lose the data. Anything, so that's why I say that anything that needs to persist should be outside the container. Once it is removed, it's gone. And let's actually look at the commands to, I'm not going to go through the entire command because we need to take at least a few questions. So let me just show you some of these. Docker stop. And you can stop one or more. If it is more, you just use, let's say, a space separated list of containers. And what happens when you stop a container? It's waiting, right? So what happens? How long it's going to wait? So there is a flow there. So when you stop a container, it sends a sig term. Sig term is signal 15, which is gracefully stopped. And then it waits for 10 seconds. That interval is configurable. You can change that interval. Default is 10. And then if it does not stop within 10 seconds, it is going to send a sig kill. Sig kill is stop right away. And that's not very graceful. So you might have some files. It's not the best way to stop a process. The same difference between kill versus kill -9. Kill -9 is sig kill. That's signal 9. Versus sig term is signal 15. So, but this is what happens when you run stop command. And if you have a running container, you cannot RM it directly. Or you have to stop it and remove it, or you have to use RM-F. So let me actually show you on by using Docker RM on a running container. So that's the stop and RM, and that's the end of my presentation there. So these containers are stopped. The stopped containers you can remove immediately with RM. Yeah, that worked. But I have these running containers, and let me try to remove one of this. If it is already running, it's going to say either you stop first or use a force remove option. Force remove will delete it, stop and delete it immediately, actually. It will just send a sig kill, I believe. So it just deletes that container, it's gone. And that's the end of my presentation. You can also, the final thing is you can also prune. So if I have a lot of images lying around, if I have, let's say, a lot of containers lying around here, I see a bunch of those. So I can delete them in one go. So Docker system df. So I have so many containers. Some of these are active, a lot of those are not. And I can use Docker system prune, or which will remove all the images which are not being used. And those are untagged, removes all the stopped containers, removes all the volumes which are not being used, and the build caches and so on. So instead of system prune, I can also use container prune, which only deletes the stopped containers. Be mindful of the fact that when you do this, anything that you have stopped intentionally and you want to use it later gets deleted as well, right? And that's the end of our presentation. At least I'm going to take some questions. I think we have 5 minutes left. So let me actually start. First, let me share the resources with you. That includes the lab guide. So what are these resources contain? This contains, okay, let me share it with everyone in the meeting. Yes, so you should see the resources there. And what does it have? It contains the lab guide and it contains the presentation that I just used here with all those illustrations and stuff. So you have access to all of that. You could download it and follow along. So what you're going to do next is tomorrow and probably the day after, till the next session happens, right? Which is, I believe, which is day after tomorrow, the same time. You would go through the labs, and it's very detailed. You will realize that it's quite detailed. You will find it quite useful already. And this is based on my years and years of experience of doing this training. So the flow is been modified multiple times. And most of the questions should have been answered there, either through the session, which you can watch a replay for. And apart from that, you can go to the lab. And if you have any further questions, just post it on the Slack channel. The treasure hunt, I'm going to share it on the Facebook group. So I'm going to do one more thing. And I want you to start, just request you to start your cameras if you can, and just wave. I'm going to take a screenshot of that and put it on the community and just share it with the community as well. And whoever can, I know, I mean, I'm in pajamas as well, so don't worry about it. So just for a few seconds, we want to see the energy. We want to see everyone here. It's amazing to, I also want to see the faces behind the names. Wow, this is really, really cool. This is really amazing, guys. Yeah, so I've just taken a snapshots of these. And hello, everyone. Yeah. Let's wait for 5 seconds. Yep, cool. That's pretty fantastic. And in front of you, I'm actually going to just share it on Facebook.
Any symbol we have? Any symbol we have for DevOps school? School of DevOps? For taking camera photos, we have any symbol like that for School of DevOps?
So the logo, yeah, we can do that, but we want to focus more on the questions now. But next time, I think we'll probably do something like that. Okay, so I'm sharing my screen and I'm going to post it on the Slack channel. Give me one moment. Not Slack, Facebook. So I've shared the link.
Gaurav, will you be sharing the video as well, the recorded, even how you?
Yes, yes. Even last time we did that.
Yeah. Okay.
So you will receive a replay. Don't worry. If you are registered on Zoom, and you are, I'm assuming, so you will receive it there. So this is the session 2. I'm just adding a post there. Please go ahead. We want to get the conversation going on Zoom as well. So sorry, the Facebook as well. So please go ahead. Add your comments, whether you like the session, what you thought about it. This is our Docker Masterclass session number 2.
Gaurav, can you post the Facebook group name and Slack channel link?
I'm just doing that. So this is our, I will be adding description a little later. And this is where the link goes. Yeah, so welcome to the community. I generally share a lot of things, including my blog post, my podcasts, and some useful resources there. And apart from that, I really want you guys to participate and just start sharing anything that you find interesting and useful as well through that Facebook group as well. So let's build a community of all these DevOps practitioners and help each other And that is the best, that's what I really want to see, right? So that's part of my mission, to see that happen. All right, so let's we have hit the clock, 9 o'clock, but if you guys are interested and if you have questions, I'm gonna be here for a few more minutes. I've already shared the resources with you. I would request you to go to Facebook right away and add a comment, what you liked about this particular session, whether you found it useful or not. And we'll spend about 10 to 15 minutes if there are questions. So go ahead, start shooting your questions.
Gaurav, Raghu here. Just want to check, like, if there is a running container, can we replace the image of it? Maybe a updated version of an image?
No, you don't. See, we are talking about immutable deployments. So any changes you create a new image, yes, but you also replace the container. We move away from the mutable aspect. So far, what we've been doing, we go to the same server and we make changes. But we don't do that with containers, and there is a reason for that. And immutable infrastructure, actually, this was introduced by Netflix, and it has become very popular these days. It actually guarantees consistency. I have been a part of ops team, and I've seen a lot of issues just because of the configuration or manual changes and changes on one specific instance of the application or the server. That becomes a headache and very difficult to debug. So it's always good to have the immutable infrastructures. In the world of containers, especially when you start deploying anything beyond development, it is all immutable infrastructure. You replace the containers, and that's why you use tools like Kubernetes and so on, so which help you do that deployment and stuff like that. So replace build a new image, replace the container. That's the way to go.
Okay, and one more question, like, if there are any secure images, how do we pull it, like, from a private repository?
You can provide credentials. Again, if the question is real, you have Docker login command if you're using Docker. If you're using Kubernetes or such, you have ways to define image pull secrets as part of your pod spec or container spec, one of that. So you can define that credentials. It's very much possible.
Okay, thank you. And okay, another question, like, if when we are stopping the container, removing the container, so you said about the term signal being initiated. So can we handle that signal somewhere so that we can have some special action done?
Can you handle the signal as in the application?
Yeah.
Yeah, so it is basically the signal is sent to the application itself. So your application should be capable of trapping that signal and taking an active, some action based on that, and which most of the applications do.
Thank you.
Yeah, I'm just taking screenshots of all of you here. I actually forgot to do that. I thought it's just one screen, but I realized that it's only 25 people that you can see on one screen. There are four windows right there, so almost like 100 people we are. That's amazing. All right. Next question.
Yeah. Hi, Gaurav. I'm Prajesh. Can you hear me?
Yes, go ahead.
Okay. So my question is, if we are running, we have a host machine in CC7, CentOS 7, and we want to run CentOS 8 Docker image. Is it possible?
Can you repeat the question again?
My question is, we have a host machine in CC7, CentOS 7.
Host, okay. You can run anything on there is no relation to what, as long as the Docker layer is there, your underlying system can be CentOS, Ubuntu, whatever, it doesn't matter. And on top of that, any other form of Linux you can run. So that's what Docker offers, really. Okay. So that's part of the root file and the image.
Okay, actually my question is that because if there is a difference, if I want to use some, for example, if I want to use, if Docker is running on CC8 and we have some kernel specific things which application is using.
Yeah, kernel specific things make it, make your, you can still use it, but your system becomes unportable. Your containers become unportable because you're going to use something from the kernel. So you should have custom kernel configured on all the systems. If it's possible to run different versions, but You cannot take the same image, same application and expect it to run everywhere else. That will not work actually, specifically if you are looking at some kernel specific things.
And I have to use same kernel version in CC8, yes? Because there is no kernel inside the Docker. Am I right?
Yes, inside the container, there is no kernel. Inside the image, there is no kernel. So whatever you're trying to use, it has to be there on the host itself or the, the host itself, yes.
Okay. So if there is a application which depends on a particular kernel in CC8, then I cannot use it.
Yeah, that's right.
Okay, thanks.
That's right. Yeah.
Hey Gaurav,
Got a quick question.
Is CNI is only for Kubernetes or?
What is that?
CNI, the container network interface, is only with Kubernetes?
No, Kubernetes is one of the users of CNI, but CNI is more like a spec. It was not even created by Kubernetes. It was created by CoreOS. CoreOS is now part of Red Hat and IBM now. So CNI is used by Kubernetes, OpenShift, CoreOS itself, the Rocket, their system, not Rocket, but CoreOS uses CNI. So CNI is a spec, it's a standard. The funny thing about the standards in container world, there are two standards: CNI, which was created by CoreOS, CNM, which was created by Docker. So the funny thing about the standard, that CNM part, is only Docker uses it. Even though they call it as a standard, it's only Docker who uses it. Almost everybody else uses CNI, including Kubernetes and OpenShift. In fact, Kubernetes experimented with both, and they picked up CNI for specific reasons. It was dependent on some key value pair, and it was Docker's developers were not very forthcoming with the changes that Kubernetes needed. So there is a story behind it. But CNI is not specific to Kubernetes. Kubernetes uses it, but it's not specific to that. You can, there are many other platforms which use it.
Okay. Yeah, thank you.
Yeah.
Hi, Gaurav. Navneet here.
Yes, Navneet.
Yeah, while creating the Docker image, when tagging that latest things, so is the best practice to always do that? Yeah, we provide a particular number like that.
Always use a specific tag. I always say that. In fact, I landed up with some issues when I created some courses also. So I use latest tag for Jenkins, and then that course run fine for a few months, and then suddenly it stopped working. The problem was Jenkins image in the in the repository was updated, latest version, and it was incompatible with everything that I had created. So you can land up with those kind of issues. Do not use latest unless you're testing and stuff. Most of the time, I would recommend using a specific version. The tag, you should be explicit, right? So don't use latest, because latest is like it's a changing target for latest. Latest is like latest fashion. The fashion keeps on changing every year, right? So that's the gist of it.
Okay, thank you.
Yeah. All right, next question.
Gaurav, one more thing. When we try to pull the image from a hub, Docker hub like that, will it uses the port 443?
You're talking about the Docker hub itself?
Yeah, let's say if you take any.
Yeah, I think so. I think so. It uses HTTPS. So HTTPS default is 443. So it needs to, if you're talking about from the point of view which port to expose from your systems, I think it would be 443 to Docker hub, because it's HTTPS.
Yeah. Okay.
Actually, I would like to know.
Your voice is not audible.
Is it audible now?
Not audible.
Is it okay? I think.
Sounds like you're in a speakerphone something and speaking from very, I don't know, far off from.
I'll ping in the chat.
All right, no problem. You can use Slack for rest of the questions also. Don't worry. We'll take the next question.
Hey, Gaurav, real quick. Usually when you run, Docker ps-a command and all, I believe that's the command. Sometime under container ID column, very first column, instead of seeing the container ID, you see missing. What does it mean? That means the container is no longer running?
No, container. Are you talking about container, or are you talking about the image? I believe it is the image.
One of these, I'm sorry, it's kind of mixed my head.
Yeah, container, I've never seen that problem. Image, yes, you see those missing components a lot of time. In fact,
in the first column. So whatever the
yeah,
command it is, I just don't know.
It's not
What
even
exactly
image
does it mean?
history. Image history. The layer ID is what you see as missing. Actually, I need to. That's an outstanding issue that I want to figure out. So I think I'll find a question answer to that and post it in the Slack.
Sometime also we saw like none in Docker images in first column.
With the layers.
First column.
First column in the layers.
Image where the image ID is shown. Sometime
All right. Image ID, I believe image ID is always shown. But when you look at the layers, the layer IDs are it shows as missing typically. None I've not seen, but if you have any specific output, please paste it in the Slack channel. I'll look into that. And this particular missing thing, it's not missing actually. There is something there. The exact answer I will find out and post it in the Slack.
Thank you. I appreciate it. I saw that you're giving us a demo earlier during today's session, and when you ran a command, I just could not remember what command it was. There were a bunch of entries were showing missing in the first column.
If you see a bunch of entries, it is the layer, image layers. So Docker image history command, to be specific, it was.
Okay, thank you so much.
I'll find that answer for you. Yep. All right.
Hey Gaurav, can you please let us know how to sign up to the workspace on Slack? We are getting error of invalid email ID.
Is that so? I see a lot of people are already joined. Let me.
Can you please share the link for the Slack channel?
I'll share the invite. I'm doing it right away. We are here till few more minutes. So if you're not able to do it, just let me know now. If you go to the link directly, I mean the direct Slack URL like schoolofdevops.slack.com, it will not work. You have to use the invitation that I've shared just now. So you have to use that specific URL in order to get enrolled. So maybe that's.
So hey Gaurav, on related note, I had a question. Many of us, we do use Slack at a workspace, right? And our real work, whatever work we do.
Sure.
And in the same Slack client, obviously since it's going to be external organization, and there could be security concern. And how do you recommend one could add, this particular workspace as which is supposedly external, right? For some of the folks like us, how do we access it? From the same
It is a namespace.
I mean, already have an active Slack channel, right? Sorry?
I believe, if I'm not wrong, Slack gives you or shows you different organizations which you can pull from that list on the top. And once you switch to that particular workspace, you only, it's not a, I don't believe it's a security concern because it's a namespace thing, and you can be in one workspace only one point of time, and the data between the workspace is not shared as far as I know. So I believe there shouldn't be a problem, and you can just, I have an organization which I use internally, and we have a Slack organization separate, and then we switch the workspace. And I believe if you just switch that workspace from that dropdown, you are exclusively in that particular named workspace. It's as good as
almost. So the point,
we can add
it. The point is either. No, can you have both sessions together within the same client? Because like say I do a lot of Slack like internally.
Same
I don't
client,
want to lose that.
Same client, yes. Once you sign up, you can configure it so that you can see it on the same client, but different workspaces. It's a drop-down menu. I believe that's what it is.
Okay.
So it's the same client.
I'll have to find out because I was having trouble, so I just used the web interface, and that's how I was able to join your Slack channel. But anyway. Thank you. I'll explore it further.
You tried, it should work, I think.
Yeah, Gaurav, one basic question on the Docker Hub versus GitHub. So GitHub, actually, we use the user ID and password, right? So can we configure the same for GitHub when we are having our own GitHub server? I mean,
Docker Hub. GitHub?
So we are using the GitHub, right?
Yes.
We are using the username and password. So some kind of authentication on the GitHub server. So can we have the same for Docker Hub as well? So we are just. So there is no authentication for the Docker Hub. So we
there is a Docker Hub. There is authentication. There is a username and password. See, all of these images that I've been pulling so far are public. This is like GitHub, right? Okay. So on GitHub, you have private repositories, public repositories. Same concept here. There are public repositories which I'm pulling from, in which case it does not ask for authentication. If it is private, it would. So I would have to use Docker login and then do it. Next session, we actually go through that.
Sure. Thank you.
Yeah, I think we'll wrap up here. Again, thanks a lot, all of you, for being here. I hope you enjoyed the session. Do go to the Facebook page, add your comment. I would be sharing the treasure hunt there. You can fetch it from there, try it out. Before the next session, make sure you try out the labs as well. Finish the labs, because unless you've learned it, you've understood the concept, but unless you actually start implementing it, you will not have it completely clarified. That will clarify a lot of concepts for you, and that's how you actually learn. So I would definitely want you to finish that lab before you come back for the next session. With that note, thank you, and we are going to sign off now. Thank you, all the best, and I'll see you in the next session.
Thank you so much, Gaurav. Appreciate it. Awesome class.
Thanks a lot. I sent a request on Facebook. Please approve, Gaurav.
I will do that right away, right after this.
Yeah, sure.
All of your requests, yes.
Thank you, Gaurav.
Thanks again.
Thank you all.
Thank you. Bye-bye.
Thanks, Gaurav.
Bye-bye.